So guys, our assignment today is collisions part 2. So we're continuing on with some problems of that. We have your inelastic collision equation, your inelastic collision over here, elastic over here. If you look at a drawing, how do you know which is which? Well, look at the after picture. If the two circles, all right, are in contact, it's inelastic. All right. If there is even a little bit of space in between, it's elastic. So first one should be what? Inelastic. Second one, inelastic. In contact, inelastic. Okay, there's space in between. It's elastic. Elastic, okay, etc. So the beginning parts, all right, we're 1 through F are just like what we were doing yesterday. They're just like what we were dealing with yesterday. Except the only factor is we're not told which exact equation we're using. So we're going to play around with this and see how to decipher which is which. First thing I wanted to start though is letter C. Now you may just want to write this down on yours that D is just like C. So I'm going to work out letter C for you guys, with you guys, and then you're going to have to do letter D on your own. So for this, looking at the after picture, is that in contact? Yeah. So since it's in contact, that is inelastic. So I'm just going to copy this guy there, going to paste it down. Oh, that's not what I wanted. All right. So here's my equation. Once you have this, now it's time to start putting the objects where they belong. Okay, well, I'm not given the mass of this first one. So what the hell do I do? Well, let's see. Are we given the velocity of it? Yes. So we have V1. Do we have the first mass, or the mass of the second guy? We do. Do we have its velocity? We do. The mass of these guys didn't change, so this is still whatever the heck it's supposed to be over here. B is still 1, and they give us a final velocity. So the only thing we're not given is M1. That's okay. So we're just going to say M instead of anything else. So we have M times 6. All right, because it would be the mass 1 plus times its velocity plus M2, which is 1 times 0, its velocity. Now it's going to equal, this one you definitely need parentheses for. The other ones you may not, but this one you should definitely have them. All right, in the inelastic collision equation. We're using the variable to represent that guy's mass as just M. It could be M sub 1, but M just works fine for this case. Plus M2 is still 1. And the final velocity that they told us was 4.8. Okay. So this is what we're left with after we have our information. So now what we need to do is you need to multiply things out, all right, and then start to simplify. Well, the first thing we can't really do much of, except I'm just going to rewrite it slightly as 6m, because I like that better, plus, what's 1 times 0? 0. So in this spot here, we have to distribute this 4.8 to what's inside the parentheses. So 4.8 times m is going to give us 4.8m plus 1 times 4.8, which is just 4.8. So this is what we're left with. What's 6m plus 0? What is anything plus 0? It's just nothing, right? It's just whatever the heck it was. So we have here 6m. Okay, that is going to equal this 4.8m plus 4.8. Now again, I'm showing this thing completely fully worked out step by step. If you can do it part in here where you can simplify it a little bit easier, go for it. But I just want to show the full thing. Okay, we got to get the m's on one side of the equation. So since we have 6m and we have 4.8m, I'm going to get rid of the 4.8. So I'm going to divide over here. You don't need to put this, but I'm just doing it again so you see the work. Divide by 4.8m, or just, yeah, 4.8m. Nope, not divide, subtract. Jesus. So what do I want to do? We can just do minus this and minus this. All right. I'll show those in clear. Again, you don't need to do this extra bit here. Okay, so if we subtract 6 minus 4.8, what are we going to be left with? We are going to be left with 1.2. So we have 1.2 m equals 4.8. Now you would divide both sides by what? 1.2. Again, guys, I'm just doing the full work part of this so we can see. Do you need to go into all of that? No, it's fine. All right, so 4.8 divided by 1.2 is going to leave us with the fact that m is equal to 4 kilograms. That will be your final answer. So now C, all right, is going to be basically, it's going to be the exact same work and setup, just a couple different numbers over here for letter D. So D is just done like C. Okay. So after we have this one, again, guys, if you need to come back to this at the end, we can. Before and after, is this, what is this? Is this a inelastic or elastic collision? Letter B, how do I know? Look at the after picture, and are they in contact? Yerp. So if that is the case, then it is an inelastic collision. So you can go back up to the top, inelastic, use that equation. Okay. All right, we have M1, we don't have the V1. We have M2, we don't, well, technically we do have V2, it's 0. We have both masses, so we have M1 and M2, and do we have the final velocity? We do, it's 6. So the only thing that we're not given here is V sub 1, or V1. Okay, so now what I'm going to do is I'm going to start plugging away. I should have 4.8 times V1 plus 2 times, or 3.2 times 0 equals the mass of the first guy, which was 4.8, plus the mass of the second guy, 3.2, times 6. So all I did, guys, was figure out what the equation was, put it underneath it, and then basically took the values from the problem that are already kind of written in and just put them in the right spot. And then from here, it's essentially just the algebra problem. Multiply, add, subtract or divide to get your final piece. Can we simplify this 4.8 times V1? No. So that dude is going to stay. 4.8 times V sub 1 plus anything times 0 is what? 0. So leave that dude just chilling. And this is going to equal 4.8 plus 3.2, that's 8, and we still have the velocity of 6. Okay, so the 0 we don't have to do anything with. All right, if this was actually a number, if it was a positive number, we would subtract it from both sides. If it was a negative number, we would add to both sides. But it's 0, so we ain't got to do none. So this is going to leave us with 4.8 V sub 1 equals, what's 8 times 6? 48. So to get V1 by itself, what would I do? Yeah, divide by 4.8. Good. So V1 would equal 48, and the unit is meters per second. So that was the only one where, on this worksheet, where we had to solve for one of the initial velocities. In all the other ones, it is going to be given. It is going to be given. Okay, so again, we will come back to this one. Okay, so don't freak out. Going up to the top, this isn't written there, so you're actually going to want to type this in, guys. Is that this is at the very, very top of the worksheet. Before our collision, there's no number there. So we want to make that a 0. And then everything else is pretty straightforward. I mean, we've solved for v prime or whatever before. In these equations, v prime is just your after collision velocity. In this case, it's VF. So you're inelastic because they're in contact after. After collision, they're in contact, so it's inelastic. This dude over here, inelastic. And then we have elastic, elastic, and elastic. So I do want to go through one of the examples of an elastic collision where their objects are bounced off of each other afterwards. So again, the strategy you should use, figure out the right equation, put the equation underneath the drawing. From there, start to fill out your pieces of information. So in letter E, what is M1? It's 3. What is the velocity of the first guy? It's 3. So we got 3 times 3. Plus, the mass is 2 times, what is the velocity? It says 2 meters per second, right? So am I just writing 2? Remember that momentum is a vector quantity. So direction matters. So since it's going in the opposite direction, we're going to say that that is moving at -2. All right, if you get a drawing like this, if the arrow is going to the left, the velocity is going to be negative. So 2 times -2. Okay, so we don't know what the new mass of the other guy is, but I'm sorry, the new velocity, but we know it's 3 times v1 prime. How do I get that? You hit V, subscript 1, go back to normal writing and just like the first apostrophe symbol. That's good. Okay, the after part of this. Mass of the second one, still 2. And the new velocity that it's moving at is a positive 4. Excuse me. All right. Start to simplify. What's 3 times 3? 9. What is 2 times a negative 2? Negative 4 equals 3v1 prime plus, what's 2 times 4? 8. Okay. So once we get here, all right, now we can kind of simplify what's going on here. I don't know what that was supposed to be. It was supposed to be like, one of these bracket looking things, but it did not turn out well. So these guys, they have no variables. Okay, we can add and or subtract as see fit, and then we got this guy over here. Again, we're trying to isolate v1 prime. So 9 plus a negative 4, what does that equal? So 5 is going to equal 3v prime or v1 prime plus 8. Again, I'm showing all the steps. If you can simplify this like last 2 steps into like the end of one, knock yourself out. But I feel like it's better for everyone if I show the full thing. How do I get v1 prime by itself? Well, first thing I got to do is get rid of the 8, yay? So subtract both sides by 8. 5 minus 8 gives me a negative 3. So we have negative 3 is equal to 3 v1 prime. And to get v1 prime by itself, divide both sides by 3. And so v1 prime will come out to equal a negative 1 meters per second. So the way to kind of think about this, guys, is remember that the total momentum before collision has got to equal the total momentum afterwards. Conservation of momentum. So I had 9 plus a negative 4, so I had 5 over here, which means I had to have 5 on this other side. So if I have a positive 8 over on this end, what do I need to add to it in order to get 5? What plus 8 equaled 5? A negative 3. So that means that this piece over here together had to come out to be a negative 3. So what times 3 gave me a negative 3? A negative 1. All right, and that would wind up kicking everybody back. If we put the negative 1 here, negative 1 times 3 is negative 3 plus 8. Add that up, that's 5. Then you have 9 over here plus a negative 4. That's 5. 5 and 5, bang, bang, boom. Okay, so there are no other ones here where we have any negative velocities. There are no other arrows being drawn to the left. Just remember to be able to complete this correctly, you got to use the correct equation. And this dude is just like one of the inelastic equations at the top. And again, I've also, guys, posted the answer key to last night's homework. So there are example problems that are there for you that are fully worked out that you can use as well. All right, so you guys are going to complete this now. Whatever you do not finish will be for homework. All right, this video I will post up later in the afternoon that you can use if you wind up getting stuck. Okay, or going back. If you go back to the homework from last night, the elastic and inelastic, if you guys were to click on that, in there I actually posted the YouTube video from doing yesterday's stuff. So that is worked out as well. So you'll have 2 videos to look at. Okay? All right.